Okay, one more quick extension video here where I'm going to talk about how to solve circuits by combining the resistors. I've forgotten I should give this some sort of voltage, so let's just make it 10 volts. And what we're going to do here is find the voltage and current in each resistor. We have a mixed circuit here. That means some elements are in series and some are in parallel with each other, which means we can't use our strategy for solving series or parallel circuits on their own. What I have to do is reduce this circuit down to either a series or parallel circuit. In order to do that, what I'm going to do is I'm going to take these two resistors right here and I'm going to combine them or replace them with an equivalent resistance. Those two resistors are in parallel. So when I have resistors in parallel, I use my reciprocal relationship to come up with the equivalent resistance of each. Sometimes it's easy to just go to decimal. Sometimes it's easier to use the fractions. I'll just use the fractions here. So a common denominator for 6 and 8 is 24. So this becomes 4 over 24. And this becomes 3 over 24. You can just use decimals in doing this. Because these decimals aren't that nice, this is just as easy for me. 7 over 24, and so when I take the reciprocal, I get 24 over 7, and here I will just convert to a decimal. 3.43. So this 6 ohms and this 8 ohms appear like a 3.43 ohm resistor when you consider them to be one thing. So I can redraw my circuit. And 10 ohm resistor staying unchanged, and those two resistors being replaced by one 3.43 ohm resistor. And what I have here now is a simple series circuit, and so I can use my strategy for solving a series circuit to get some information about it. I'm going to start my Kirchhoff's voltage loop down here. I'm going to go up 10 volts through the battery, down V1, and then down V2, and then back to that spot. So I go up 10, and then down V1, and down V2. Now here V1 is equal to the current times the resistance. And because this is a series circuit, the current everywhere within the circuit has to be constant. And so I don't have to say I1 here, I can just say I. And then when I do the same thing down here, because that current is the same, those I's are constant, they're the same value, so then I can reduce my equation down to just one variable. V1 is equal to I times 10 ohms. V2 is equal to I times my 3.43 ohms. 10 volts is equal to I 10 ohms plus I 3.43 ohms. And now, again, I have 10 currents and I have 3.43 currents, so they're like terms, so I can say I have 13.43 ohms times current here, combining like terms, and then isolating for current. Okay, I don't know why my calculator's conked out on me here. Alright, sorry for that pause there. My calculator sort of died on me. I don't know what's going on. So I just replaced them. Anyways, 10 divided by 13.43 gets me a current of 0.745 amps. I'm rounding that value, but there it is. And then if I go up to this circuit, what's tricky about this is I need to know how to use this value in this original circuit to get a little bit more information to solve what I'm doing here. The key to this is to recognize that this 10 ohm resistor hasn't been affected by the change that we made here. See, we changed these two resistors into this, but we left that guy alone. So if this current of 0.745 amps is flowing around this circuit, then that's the current in that 10 ohm resistor. With that one extra piece of information, it becomes much easier to solve the overall circuit. So what I can do now with that one extra piece of information is go back to my original circuit, add that piece of information, and we'll see that it makes it easier to solve. So originally I had my 10 volt battery, my 10 ohm resistor, I can't remember which one was on the inside, I'll go look in a second, my other two resistors. This one's 6, this one's 8. So this one's my 6 ohm, and this one's my 8 ohm. And now I know that the current that went through the battery and through this 10 ohm resistor is 0.745 amps. With that in hand, I can start at spot number 1, and I can use Ohm's law to determine the current, or to determine, the voltage at that spot. 0.745 amps. Resistance of 10 ohms, so I get a voltage of 7.45 volts. Now I can do my loops where I go through my two resistors separately. So loop number 1 here, I'll go down the center. I go up my 10 volt battery, down my 7.45 volts, and I'm left with whatever I'm going to have on, I'll call this resistor 2. To go back down. So 10 minus 7.45 leaves me with V2 at 2.55 volts. So this is 2.55 volts. Now I can do the same thing but using the loop that goes around the outside, and I'm going to get the exact same equation. So this one is also 2.55 volts. Finally, at location 2 and 3, I can use Ohm's law to determine the current in each location. 2.55 volts and a resistance at not 60. Actually, hold on. Go back to the pen. 6 ohms. I get a current of 0.425 amps. And similarly, at location 3, dividing both sides by 8 to isolate for current. Get a current of 0.318, or 31, I'll just round it to 9 amps. Now, a nice little trick here is because of the current law. If we look at I1 and I2 and I3, we see I1 is going into this junction. It must feed I2 and I3, so I1 should be equal to I2 and I3. Now that I have all that information, I can check and see if that's true. 0.745 amps should be equal to 0.425 amps and 0.319 amps. And if I add these two, I'm going to get 0.744 amps. And the difference between these two numbers is just that I've done some rounding as I've gone through. Otherwise, this worked out exactly. And so we can happily view this as our check to see that we have correctly got all the currents and resistances in the circuit. There's I3, I2, I1, V1, V2, and V3. So that's how you can combine resistors. I know it's a little bit long and probably beyond the normal grade 9 level, but again, this is for those of you that are looking for a little extension, something a little more challenging to give you the idea of what kind of stuff you're going to learn about if you want to go on further and take something like computer engineering or grade 11 physics, where you're going to talk about and learn more about electricity.